Yeah, hello everybody. Today we discuss about MSP430 introduction. So in this class we cover the features of MSP430 and its pin diagram followed by its architectural diagram or the block diagram of it. Yeah, you know very well about MSP430 that MSP nothing but mixed signal processing means it deals not only the digital also the analog signals because most of the signals by default analog in nature. So to deal them, for example, the sensors, most of the sensor are going to take analog values because the natural values are going to be in analog. Therefore, the sensors outputs are also going to be the analog. So for processing of those signals, the microcontroller should process those signals. Hence, here we're having a controller calling it as MSP, mixed signal processor. So this mixed signal processor is actually meant for low power consumption. Hence, it is deal with the ultra low power capability because of five low power modes like low power mode 0, low power mode 1, and so on up to low power mode 4. And this is based upon 16-bit RISC. It is based upon the 16-bit RISC-based system, and it also contains larger register file each with 16 bits wide. So because of this, the speed of computation is going to be more because whatever the data that we require regularly that can be put in the register itself rather than fetching from the memory. Hence, the speed of computation is also going to be increases, and it is also containing intelligent peripherals like ADC, DMA, watchdog timer, IOS, ADC, DAC, and flexible clock system and universal serial communication interface. So these make MSP430 excellent for dealing various embedded applications, and it also for low cost. It is also containing extensive interrupt capability, and it's also having an interrupt vector table which is going to be available from the memory, and it is also containing seven addressing modes. Of course, in seven, source are having access for seven addressing modes, but for destination, it have only access for four addressing modes. And coming to the instructions, it contains 27 native instructions and 24 emulated instructions. It's also containing fast hex to decimal conversion. And other than these, if you go if you go through the low power consumption of it, in active mode it takes about 250 microamperes of current, but whereas coming to the RTC mode and RAM, these are the low power modes, it takes only zero point 0.8 and zero point 0.1 microamperes only. So in this way, power consumption is going to be reduced drastically because of low power modes that are available in MSP430. Because of that, and the operating voltage is also in between only 1.8 volts to the 3.6 volts, and it is also having a special module calling it as VOR, brown out reset. Whenever it gets powered in the dangerous levels, then it resets the system. So these are the various features of the MSB 430 that are available. And let me see now the block diagram of it. Please wait for a while. I will take you to the diagram of it. Yeah, sorry for the late. It we see it's a pin diagram and followed by its architecture diagram. So this is as simple as containing only the 14 pins for the versions like 2003 and 2013. If you see this microcontroller, it is having only 14 pins with a very minimum number of pins, but each pin is going to allocate with multiple number of functionalities to reduce the cost and to reduce various wiring complexity. And here we are having only 14 pins, and each pin will be having of multiple functionalities. And if you observe the first thing, VCC and the VSS that are at pin number 1 and pin number 14. So these are for supply voltage and for providing a ground voltage, supply voltage as well as for the ground voltage. Okay, and go to the next one, P1.02, P1.7, and P2.6 and P2.7. So these are actually the input and output ports, which are actually as a part of P1 and P2. Based upon the version, the number of ports are going to be increases. For this version 2003 and 2013, so these are the totally uh, 10 pins are available for GPIO input output case. And coming to the another set of pins here, TA clock, TA0 and TA1. So these are regarding timer A for providing clock to the timer A, and TA0 and TA1 are going to be the input and outputs of the respective timer A. And coming to the another set of clock here, another set of signals, A0 minus, A0 plus, up to A4 plus and A4 minus. So these are the analog inputs for the analog to digital converter. So, and for analog to digital conversion, it requires even the reference voltage. That reference VRF is available at the point pin number 5. And other than that, so A clock and SM clock are also available. A clock and SM clock are going to be the clock signal, so which are going to be the microcontroller to operate the CPU, to operate, sorry, to operate various peripherals, A clock for the slow peripherals and SM clock for the fast peripherals. And coming to the another set here, S clock, STO and SCL. That is nothing but for serial interface clock, serial interface data line, serial interface clock line. So these are going to be the three three inputs or outputs for dealing a universal serial interface such as SPI and I2C. These are the communication protocols for dealing with input or output device. And X in and X out are going to be the input and output to the crystal oscillator. The crystal oscillator is the reason for providing the stable frequency, and reset bar is going to be the active low reset pin. So in normal operation, this is going to be high. In reset operation, this is going to be low. And coming to NMI, NMI is going to be the non-maskable interrupt. So whenever non-maskable interrupt occurs, it must and should be executed, and remaining TCK, TMS, TS clock, TDI, TDO, test. These are all the signals related to the JTAG, and SBWTDIO, SPWTCK. These are regarding SPY by wire. These two, JTAG and SPY by wire. These two are for debugging the code. For the purpose of debugging, this full JTAG interface or the SPY by wire are going to be useful. SPY by wire generally useful for alternative to the JTAG. In some versions, only JTAG is available. In the latest versions, the SPY by wire is also using. Yeah, let me goes to the block diagram, functional block diagram of MSP430, 2003 and 2013. If you observe here, the main part of microcontroller is the CPU. It itself contains ALU as well some CPU registers. Whatever the total 16 registers are there that are available here. And so this is the main part of the microcontroller, and these are the various peripherals that are available. So these two are the memory part, and these six are the main peripherals of the MSP430. And brownout protection, this is for when the MSP430 receives voltage in dangerous level to reset the entire module, entire kit. This is going to be useful. And this basic clock system, this is the clock module which is going to provide a clock to operate various peripherals and CPU of the system. Let me go through each and every module here. So first of all, basic clock system. So for basic clock system, the inputs is the Xin, that is crystal input, because here it will be containing crystal oscillator. So crystal oscillator get input from X in and gives outputs like X out, A clock, SM clock, and M clock. This X out is useful for clocking the external device. Remaining M clock, A clock, and SM clock are for dealing internally. M clock specially for the CPU, and A clock for the low speed peripherals, SM clock for the high speed peripherals. For dealing this, we are having these. And other than this, we are having MAB and MDB, where MAB is a memory address bus and MDB are going to the memory data bus. So for dealing address and data, these two buses are there, and these two buses are interfacing CPU with various memory and peripherals of the microcontroller that you are observing here. And memory, coming to the memory, so for code, flash is required. For data, RAM is required. And for the constant data also, we require the flash. So 1 KB in 2003, 2 KB in 2013, whereas RAM, so for both versions, it is only 128 bytes and 128 bytes. And coming to the peripherals, like here, A to D converter, whenever we are dealing with analog signals, outputs of various sensors we are going to give to the AID, and able to give the digital value, and according to that digital value the microprocessor going to process it. And we are having totally 10 pins, 8 pins from port 1, 2 pins from port 2. Totally 10 pins are available for processing general input output, as well for interrupts, timer actions, DMA actions. For various functionalities, these 8 pins are 10 pins are going to be useful. And coming to the timer, so timer is going to provide various functionalities like alarm, scheduling, and it is going to also configure interrupts. For all these, this basic timer is going to be useful. And there is one more timer calling it as watchdog timer. This is a special timer which is going to deal whenever the microcontroller enters into an infinite loop, or stuck in an infinite loop, or enters into some fault condition. To reset that microcontroller, we are going to use of this watchdog timer. And finally, the USI, Universal Serial Interface. So like UART, I2C, SPI, these are all available here. So for interacting with the external world, to extend the application, to extend the uses of this MSP430. So these are all about the features of MSP430, followed by the pin diagram of MSP430, and finally the functional bar diagram of MSP430. Thank you, Anada.